All right, I think we can go ahead and get started. So I am very excited to introduce Dr. Nick Golovin, SVP of Enterprise Data Platform at CData. He is going to join us today to present on his session, which is Fast Tracking Enterprise AI, the game-changing synergy of data integration, Gen AI, and RAG. So, Dr. Nick, we are super excited to have you on stage today, and I will let you take it away.
Yeah. Thank you very much, Marie, and welcome everybody. It's great to be here today and share this virtual space with all of you. My goal in this session is to talk about some of the exciting developments that we are doing with our partners and customers in the area of enterprise data and IT and AI. Specifically, we'll explore how technologies like data virtualization, Gen AI, and RAG are coming together on the foundation of CData products to fast-track enterprise AI. I will actually start by sharing my very personal view on the history of the AI, then talk about the technical evolution. We'll go on a deeper dive into CData's talk-to-data architecture, and then finish off with some outlook and customer projects and question and answer session. So my very personal view on the AI history. So my personal background is technical and also academic. So I was doing university research. In my past years, I was concentrating on data integration and data virtualization specifically. That's also the core of what I'm doing at CData. But in my past, I was actually working in university research at the intersection of data integration and AI or machine learning topics. And I think from this point of view, I can give some perspective on this. And like my personal view is that AI has been a fascinating journey all along, not just in the recent years, but also across decades with all those ups and downs. And it has experienced repeated moments of inspiration, but also moments and trough of disillusionment and stagnation. So the earlier ones are known as AI winters. Now, as the overall climate is warming, and I think we're now in a phase where the cool downs are getting shorter and shallower, and spikes in the innovation are increasingly hot and impressive. So I have seen machine learning coming and getting big, but before it really faded, all the hype faded off, data science came, and before the hype of data science faded off, now we have the magnificent ChatGPT launch some years ago. And what's next? What's next? And talking about what's next, I think it's good to reflect on what Amit was saying at his note yesterday about how a lot of innovations are going from individual use to company use. And I think, and I feel in my conversation with companies we're talking to, that the next big thing is use of Gen AI in the enterprises. And many people and companies are working towards this goal. Now, what does it really mean, data integration and Gen AI? What is the technical, where do we stand technically? I would start with a Gartner quote, which I think is very interesting, and I would subscribe to it immediately. Gartner said that AI is pushing organizations towards decision centricity, focusing on outcomes. And that's interesting because how come AI can do so many things? It can help you write code, it can help create marketing material, it can translate languages, but how come it's pushing organizations to decision centricity? But this is what I feel as well. So it seems to be the most important thing, support of decision making for the companies. Interesting is, however, also comparison with this slide. It's also from Gartner, and it tells us where generative AI is effective and where it's not effective. And interesting is that probably the most sought after capability, decision intelligence, is where AI actually has low effectiveness. Well, that's kind of sad, right? So we need it, but it's not good. And this is where help comes from this other important capability that GenAI has. This is a conversational interfaces. And I think that these interfaces could serve as a critical entry point for applying AI in the enterprises. And what needs to happen to achieve this breakthrough based on this user interface capability? So I think two big things need to happen. On one side, we need to get the technology right. So we need to adapt the current AI technologies and their deployments to better serve data use cases. That's one side. The other side is we also need to have the right expectations from AI. So to be honest, I'm a technical guy. So my expectation from a machine is always that it needs to give predictable, 100% correct results at all times, right? So I was one of the disillusioned ones when I realized how much ChatGPT hallucinating, for example. But then over time, working on our internal Gen AI projects, I changed my mind, and I'll just tell you an anecdote. So I was testing AI with some sales data, and I was asking for sales data from Southeast Asia. And the AI chatbot gave me some information to include sales in the city of Valencia. And that's where I thought, oh, got you, hallucinating. Because of course I'm living in Europe, so my Valencia is here around the corner in Spain. What they didn't realize is that there are 9 Valencias all around the world, and one of them is in Philippines. So actually I was wrong and AI was right. Yeah. So it kind of changed my perspective. I think we need to shift our perspective from looking at AI as a machine, like a just report generator, into kind of almost a human assistance, human colleague, which can make mistakes and will make mistakes, but at the same time, it's a very, very knowledgeable colleague. And once we realize this and also make technical preparations to organize this conversation with this colleague, I think we have really limitless possibilities on working better with enterprise data using AI. Yeah, so how can it work out technically? So I will not go too deep on all of the deployment strategies of LLMs we see in the enterprises. Just to kind of paint the big picture, everybody was starting with just adding additional enterprise-specific information to the context in one way or another, be it into the prompt or into static embeddings. Cheap and easy to start, but not really ticking off any of the enterprise relevant checkboxes, and at times also just not really working well technically. On the other side, there is of course like the Porsche ways of doing this. It's like training models or maybe fine-tuning models, a bit more expensive, but quite expensive to be honest. But it's actually not ticking the check boxes on some of the important things out there. And it seems that the approach which is ticking the check boxes and is also acceptable from the point of view of affordability is RAG, retrieval-augmented generation. And what we see is that more and more companies are going down this road. And this combines the capabilities of plugging vast amounts of internal company knowledge into the operation of LLMs from one side, but combine it with fast response times. And also, since it includes cooperating with external data retrieval engines, it can also provide correctness on the quantitative data. It can provide dynamic real-time data, and it can provide for data governance and security. So how does the reference implementation of RAG look in our case? So that's data virtuality RAG component. So that's a chat interface. I will not go too deeper into this because I think by now you have all seen many implementations of these chat-based interfaces where you can get some information from a chatbot. You can also get some tables rendered. You can get some graphics rendered. I think that's important to get this UX part right. But for us, it will be today important to understand how can we actually make sure that what are the steps behind the scenes, and how can we make sure that it provides good answers and the right answers. And this is something which I think is best seen on an example, just going through the architecture and seeing how what things are happening while we do it. So we start with the user posing a query, like show me some sales data from this geography and from this specific product category. It goes on to enriching this with additional business context. Because, for example, the user was asking for net sales. What is net sales? Every company has a different definition of this. Also definition of geographies, definition of product categories can be different for each company. In our case, we expect this would be a kind of static information provided by tokenizing some wiki or some process playbooks which exist on the business side in the enterprises. And from there, this enriched query goes to the next step. It goes to our vector search interface, which is a very important part of REG. And there it gets enriched with technical information. So the data foundation is looking what are the best tables, what are the best technical means to provide answer to this information, what are the tables, what are the columns, what are the joint candidates, and so on. And after this, we go to the core LLM and ask the core LLM to generate a SQL query based on all this additional business and technical information. And the next step, which I think is missing in many architectures I've seen, but it has proven to be very important for us in our practical tests, is the consistency and correction step. It's something similar to actor critic model. Basically, there's an additional LLM which is looking onto what main LLM is generating and providing its assessment of quality. And if you think that the quality is not enough, then it can be that the core LLM needs to go and redo its work and try better. After this step, we run a SQL query. It runs on our data foundation, which over the REST interface, which provides access to all the underlying data sources, which I will talk about a bit later. And from there, the results get formatted by the core LLM and shown to the user in the form of table. In this case, could also be graphic, could be something else. One additional step, which is also important for this consistency and correction LLM, but not only for it, is the optional possibility to send the results for human review. And this is something which I think also is essential for practical usefulness of such architectures, because even when I think of me working in an enterprise and not having any AI, but really asking BI developers to provide me a report with something, it never works 100% the first time. It's usually an iterative process, and I was actually more on the developer side, and the business users were always telling my team, yeah, okay, it looks good, but can you check this one, or can you change this one, or that one doesn't look quite right, yeah. And this iterative process is very important, I think, to get to the practical results. And this is something which is done by data steward in this case, and the corrections of data steward, the feedback of data steward, immediately gets posted into the conversation with the user, but is also used to inform the operation of both the LLMs in the core. By the way, all this cooperation between LLMs and other components is orchestrated via LangChain library. Yeah, so what are the important benefits? What do you get from this CData architecture, which you don't get in other places? It's the following things. First of all, CData is connectivity company, and connectors are a great part of this value that we are providing. First of all, we are able to easily plug into the system data sources which are non-relational, like Salesforce, HubSpot, Jira, many other things. We'll talk SQL language, making it very easy to plug it into this kind of architecture. The next thing is that the connectors also have knowledge of a lot of data sources, knowledge of metadata, knowledge of semantics. So they know what is issue for Jira, they know what is opportunity for Salesforce, and so on. And last but not least, especially as Mike Gutierrez was mentioning yesterday, real-time data capabilities. We are providing data in real time. The next component is the semantic layer, and this is also a very important part. This is where you have business use with business-friendly column names and descriptions. This is where you have data prepared and transformed for querying by LLM. Again, it also has real-time capability, but it also has capabilities for materialization, to increase the performance, to replicate some of the data so that we can have cleansed data and historized data as part of the data foundation. So this is a powerful component that enables your AI. We have the two interfaces here, more classical relational SQL REST and vector search interface. And one thing which is common thing which is important to both is that they are under the same data security and data permissions layer. For example, if a user who is not allowed to see HR data is trying to ask for HR data, it's not only that the SQL interface will not give them this data, also the vector interface will not show any availability of any tables which the user are not allowed to see. And of course, also on the data side, there are permissions applied. There are row permissions, column masking, and so on. As a continuation of the same topic, also SSO capabilities across the platform. So actually, when the user is connecting to the web interface on one side, the data engine on the other side knows who it is and what are we allowed to show to this user. And also along the same track, audit capabilities across the architecture, but also concentrated in the semantic layer. We can always track who was accessing data, when, who was doing changes to the data models, when, and so on. So to summarize, what are the things that we provide to customers and to partners who build enterprise AI use cases? First of all, we provide the data foundation, which is very important, and this includes the connections, it includes the semantic layer I was talking about, that includes both data and vector interfaces to interact with the LLM part of the architecture. For the LLM part, we also provide fine-tuned LLMs for SQL generation, LLMs which can also work inside the company, so on-premise, so to say, and generate the right SQL syntax for us. And we also provide a sample chat-based talk to your data UI so that you can jumpstart your AI user interface. And this is in addition to providing a kind of standardized generic interface in our products. At this point, I would like to invite everybody to join our AI Foundations pilot program. Right now, we are working with a number of customers and partners on their AI use cases. So there are, for example, there's a British real estate management company which is working with us to increase the throughput of providing important data to their strategic partners. There are some mechanical engineering companies in Germany who are working with us to provide their employees with better visibility into their complex production processes. But we are looking for more cooperations from different geographies, from different verticals. Just drop us a line. Here is email shown on the screen. We are happy to talk to you about your AI use cases. Yeah, and thank you very much for your attention. And let's look at Q&A.
Awesome. Thank you, Nick. That was a great session and a really great deep dive into the technical architecture for AI. So thank you for that. And we do have time for maybe one or two questions before we continue on with the audience. So the first question that I was really curious to dig into was that you noted one of the things holding back enterprise use cases for AI is that enterprises have a lower tolerance for hallucinations than individuals. And I am curious that, you mentioned that you could address this within the context of data integration. So, being able to manage hallucinations for an enterprise with better data management. Could you elaborate on that point and how you see that coming together?
Yeah. So I would summarize. I was touching on this in different points of the talk, but I can summarize these points now. So first of all, and this is like not specific to us, but it's more specific to the RAG architecture, that the quantitative work should be offloaded to quantitative engines. So LLMs are not good in doing 2 plus 2. I mean, 2 plus 2 they can now, but anything similar to 2 plus 2 but more complex, they're just not good at it. So first thing is offloading the quantitative work to external engines. The other thing is using more sophisticated GenAI setups. So I mentioned this. What we use for reducing the hallucinations is using this actor critic model, where essentially one model is creating SQL statements, and yeah, it's mostly good at it, but it's not excluded that it can hallucinate. But the other model is watching out, and it's a different type of model. So it may have hallucinations, but it's a different hallucinations, and it's actually giving feedback to the first model so that together they achieve much better results. That's the second thing. And the third thing is really what I mentioned as well is change in the mindset of how we look at this, because LLMs can provide funny results, but like everybody probably will have colleagues who provided funny results once in a while, and probably each one of us was once this colleague which provided funny and wrong results, where somebody said, okay, this can't be wrong, right? So let's look at it together.
Yeah.
And kind of the same kind of attitude, like let's work together with AI on improving these results. This iterative approach is actually the third key component for me to grow the adoption of AI in this enterprise data environment.
That's wonderful. I think we only have about a minute left. So I'm not sure we have time for another question, Nick. But again, thank you for all the time today and for sharing all those insights. I thought it was really interesting to kind of continue our conversation on AI and dive a little bit deeper into the architecture.